KD3 that we just described before have a query in square of n plus k, the number of node report in a query. So when the number of report node is small, the query time is relatively high because square of n is large. So we want to try something better. And what is something better is range tree. It's something better because the cost of a query will be only log square of n. So now a query will be of log square plus k. But you have to pay a price for that. And the price is the following. Now the storage will be on O the n log n. So you will store more. What you will store more? Basically, you will store a range tree for all level. So all node you will store an additional x binary tree. So you will have a binary tree in x coordinate, and at each intermediate node you will store an additional binary tree, and that will provide you a cost of n log n. You will tell me it will be n squared? No, because each binary tree will be smaller and smaller, the additional one. Okay, it will be not 2 binary tree, it will be a lot of y binary tree for each node. But at the price of this additional cost, we can reduce the query. Okay, alors this is the way to build each range tree. So each tree in the y coordinate at each node, and to perform the query it will be defined in the following way. That is just algorithm. So basically the idea is the following: you increase the storage but the query is fast. Now we have still some questions. Let us try to summarize the performance of a range tree. You have the following performance. The space required is now O the n log n. Building will be O the n log n also, and the query will be now on O the k plus log square the n. That means that is the range tree. If you compare to the KD tree, the space was linear, but the query was O the k plus square n. So we increase the space, the data structure requires more space, but the query is faster. So let's go to the next step, or to improve the final stuff. It's called the fractional cascading. But it will be the next podcast. Be ready for the next episode.